We are continuing section 6.3 on exponential functions, and this is exponential equations that we're solving using the strategy. If a to the u equals a to the v, then u equals v. In other words, write both sides with the same base if possible, and if you can do that, then you can set the exponents equal and solve. So we're on part E. 5 to the x squared plus 8 equals 125 to the 2x. So the question would be, can we write both sides with the same base? Well, 5 can't be broken down any further, but can we write 125 with a base of 5? So you would play with your calculator a minute. 5 squares, 25, 5 cubed is 125. So we'll write 5 to the x squared plus 8 equals 5 cubed to the 2x. Don't do too many things in one step so you can avoid mistakes. So that's 5 to the x squared plus 8. And what do we do with these exponents here? Multiply, that's right. 5 to the 6x. Now we can use our strategy and set the exponents equal to each other. We recognize that we have a quadratic, so we want to set this equal to 0. So we have x squared minus 6x plus 8 equals 0. And we'll see if this will factor. And let's see, what would it be? Negative 2 and negative 4. So x equals 2 and x equals 4. And you can go back and check. And both of those do work. So we haven't made a mistake. We're not looking for extraneous solutions. We won't generate any extraneous solutions. Checking is just to see if you made a mistake. That's all. We're not looking to maybe toss out one or the other. We just want to make sure we didn't make an error. All right, part F. We have 9 to the 2x times 27 to the x squared equals 3 to the negative 1. So the smallest number here is 3. Can we write all of these with a base of 3? Yes, we can write 9 as 3 squared. It's raised to the 2x times 27 as 3 cubed, it's raised to the x squared, and then we have 3 to the negative 1. Now we don't quite have if a to the u equals a to the v. We have to combine these two together. But how do we do it? When you have x squared times x cubed, what would you do with those? This is the same idea as having an x squared times an x cubed. What do we do with those exponents? You add them, right? So that's x to the 2 plus 3. So that's what we'll do here. Okay, this will be, well, before we even do that, we've got to get rid of these parentheses, right? So let's do that first. I'm getting ahead of myself. We don't just have 3 to some power, right? We've got to get rid of the parentheses. Then we'll come back to that idea, but we know we're going to need that, right? So this is 3 to the 2 times 2x, or 3 to the 4x, times 3 to the 3 times x squared, or 3 to the 3x squared. Now, this is where I should have said, okay, now this is what we have, right? I'm just getting in a hurry. Okay, so we know that what we'll do with these, this is where you multiply the exponents, right? When you raise the power to a power. But here, when we have the base to a power times the same base to a power, that's when you add. So what we have is 4x plus 3x squared equals 3 to the negative 1. Okay. Sorry, equals negative 1. Taking all those exponents and setting them. Let's fix that. Okay. 3 to the 4x plus 3x squared. We need this step. 3 to the negative 1. There we go. Sometimes, I'm demonstrating how you can make mistakes if you try to skip them, and skip steps, and that's what I was doing. So, yeah, that's a good example of how that can happen. All right. So we multiplied here, and now we've added, and now we have if a to the u equals a to the v, then u equals v. Now we can write it with just the exponents, and we have a quadratic. So I like, as I've said before, I like my coefficient of x squared to be positive. So I'm going to keep it on this side, 3x squared plus 4x and just add 1 to both sides. And now see if I can factor this. To get 3x squared, the only way is to have a 3x and an x. And to get 1, the only way is to have 1 times 1, right? So will that get me the 4x in the middle? If I make these both positive, it works out. Okay, so 3x plus 1 equals 0. 3x equals negative 1, and x equals negative 1/3. X plus 1 equals 0, x equals negative 1. So our solution set is negative 1/3, negative 1. Again, you can go back and check. Okay, let's see if we can get through this next one without making any goofy mistakes. All right, the base here, we see this base of e being used. On the left, we already have just e to 2x minus 1. That's it. So if I can get the right to be all just e to some power, then I'll be ready to go with that strategy. But we've got some work to do first. 1 over e to the 3x can be rewritten as what? E to the negative 3x, right? That's the same as 1 over e to the positive 3x times, and then what do we do here with these exponents? We multiply, right? E to the negative 4x. Okay, so we have e to the 2x minus 1 on the left. Now I want to combine these. So what do? We add those exponents. Negative 3x plus negative 4x, negative 7x. Now we can use our strategy. So 2x minus 1 has to equal negative 7x. And let's add 7x to both sides. And what do we have? 9x minus 1 equals 0. Add 1 to both sides. 9x equals 1. Divide by 9. 1/9. So our solution set is 1/9. Okay, last one. We have 1/2, we have 8, we have 2. We know we can write this 1/2 as 2 to the negative 1, so let's go with that base of 2. Can we write 8 with a base of 2? Yes, it's 2 cubed, right? So in this parentheses, it's 2 to the negative 1 raised to the x minus 5. In this parentheses, it's 2 cubed raised to the x. And then here we have our 2 to the, sorry, it's an exponent, 2 to the x squared. Okay, so let's get rid of these parentheses. So this is 2 to the negative 1 times x minus 5. So that's going to be 2 to the negative x plus 5, right? Multiply both of these by negative 1. And this will be 2 to the 3x times 2 to the x squared. So we're seeing that same thing that we've seen before. Now, to combine on the right-hand side, these two, we add the exponents. 2 to the 3x plus x squared. And now we can use our strategy. Negative x plus 5 equals 3x plus x squared. Keeping my x squared positive, it'll stay over here. So let's see, I'll add x. 5 equals 4x plus x squared. Subtract 5. And writing it in descending powers here, I've got a positive x squared, positive 4x, and a minus 5. And let's see if that'll factor. What would it be? Positive 5 and negative 1. So x equals negative 5 and x equals positive 1. Negative 5 and positive 1. Okay, so we saw a lot of the same strategies used over and over. Anytime you can solve an exponential equation this way by writing both sides with the same base, that's going to be the easier way. But we will find out soon what to do when you can't write both sides with the same base.